it is the normal reaction. So now it should be completed in single step. Same reaction occurs in the two steps. Okay, it is the single step mechanism. We can write what it is here, the single step mechanism. Next, I want to take which one here, the several step mechanism. I want to take which one here, the several step mechanism. Same example. At first step, carbon solid is nothing but graphite on reacts with half mole of the oxygen gas. On reacts with which one here, the half mole of the oxygen gas. So it will forms here the carbon monoxide at first. What is the intermediate compound here, the carbon monoxide. For this one, I want to give the delta H1. Why? Because it is the several steps. In that several step, first step, for the first step, delta H1 is equal to, I want to take here the nearly minus 11.5 kilojoules per moles. Okay, now I am taking here the second step. In the second step, same as it is carbon monoxide gaseous state, on reacts with the half mole of the oxygen and forms here the carbon dioxide, and forms which one here, the carbon dioxide. So for this one, nearly delta H2 is equal to minus 283.0 kilojoules per mole. Okay, so it is the several step mechanism, it is the single step mechanism according to Hess Law. Okay, we can write what it is here, the according to Hess Law. Okay, delta H is equal to delta H1 plus delta H2. What is the delta H here? The minus 393.5 kilojoules. If you add these values, you can also got what is the value? 393.5 kilojoules per mole. That means it is the use of the Hess Law. Okay, what is the definition of the Hess Law here? The energy change is the same whether the reaction takes place in a single step or several steps. That is called as Hess Law of conservation. In the Hess Law of conservation, I am taking as one of the chemical example, formation of which one here, the carbon dioxide. Okay, so formation of carbon dioxide involves two types of the mechanism: single step mechanism, several step mechanism. In single step mechanism, so carbon solid state is nothing but which one I am taking here, graphite. When reacts with the oxygen, it will form here the carbon dioxide. Okay, so that carbon dioxide necessary here, the minus means what is the meaning of minus here, the heat evolves. So minus 393.5 joules per mole. So that should be occurs in the several step mechanism. In the several step, this reaction possesses two steps. The two steps enthalpy change is delta H1, delta H2. According to Hess Law, delta H is equal to delta H1 plus delta H2. That is also proved. It is the Hess Law of conservation. Okay, it is very, very, very important from this chapter. Next of all, before the class, before the Hess Law, I explained about the enthalpies. Those enthalpies are nothing but phase transformation and standard condition we are completed. Now I want to explain the same enthalpy values. Now I want to explain which one here, the same enthalpy values for combustion. Okay, so enthalpy of, okay, you can write the standard, use compulsory, what it is here, the standard enthalpy of combustion. Okay, standard enthalpy of combustion. So what is the combustion? Simple, the compound which is burnt in the oxygen, in presence of oxygen, that is called as combustion. Okay, so what is the word here using? Standard enthalpy. So standard enthalpy is nothing but the heat evolved. Why? Because in the combustion always heat energy will be evolved. So that's why it is called as standard enthalpies. Heat evolves. Okay, heat evolves. You can write what is the word here. Heat evolves when 1 mole of substance burn completely, okay, in presence of excess of oxygen, in presence of excess of oxygen. So that is called as the standard enthalpy combustion. Okay, normally enthalpy is nothing but releasing energy or absorbing energy, but in the combustion process always heat evolves. So whenever the heat evolves here, 1 mole of substance burnt completely in presence of excess of oxygen, that should be called as the standard enthalpy of combustion. So standard enthalpy combustion, already I given the example, all hydrocarbons is nothing but alkanes, alkenes, alkynes. Of course, in our aromatic hydrocarbon, benzene is also involved in the combustion and heat evolves. But already well known example, it is nothing but I am taking ethylene, C2H4, oxygen, it will give here the carbon dioxide and as well as here the water. For the balancing of this equation, I am taking the 2 moles and I am here taking the 2 moles and here also I am taking the 2 moles. Okay, so it is also the best example of which one here, the standard enthalpy of combustion. Okay, so here the oxygen, in presence of oxygen occurring reaction is called as the combustion. Next one, standard enthalpy of atomization. Next one I want to explain which one here, the standard enthalpy of atomization. Standard enthalpy of atomization. So standard enthalpy of atomization, what is the meaning of atomization? Simple one, the compound converting into atoms. Okay, the compound converting into here the atoms is nothing but which takes place here, the bonds which are present in the compound, that should be cleavage, and gives which one here, the atoms. For example, hydrogen is there, you can give here the 2 hydrogen. For this one you required or released energy is called as what it is here, the standard enthalpy of atomization. Here the 2 hydrogen atoms are formed. 2 hydrogen atoms are formed. Okay, so next of all, standard enthalpy of bond. Okay, standard bond enthalpy. I am taking the one more, what it is here, the standard bond enthalpy. Standard bond enthalpy. Okay, so standard bond enthalpy is nothing but here, simply we can take that one, the bond enthalpy. Okay, the energy which is required for the cleavage of 1 mole type of the bond, that is called as the bond enthalpy. It is also the same example for giving the standard bond enthalpy. Okay, next one, standard enthalpy of ionization. Next one, what it is here, the standard enthalpy of ionization. So ionization is nothing but so converting of the 1 mole substance into ions. For the required energy is called as here standard enthalpy of which one here, standard enthalpy of ionization. Standard enthalpy of ionization. Okay, so these are the words which are related to the enthalpy. Okay, so after this one we are also gives that one lattice energy. After that one we have to discuss which one here, the lattice energy. So lattice energy is also same, the absorbing or revolving releasing energy. Okay, whenever the smallest atoms are get together and forms here the one of the contains crystal or lattice, that is called as here the lattice energy. Okay, these are also totally related about the words enthalpies. Okay, so it is the information about enthalpies. Okay, standard enthalpy of combustion, standard enthalpy of atomization, standard bond enthalpy, standard enthalpy of ionization, and also we discussed about which one here, the lattice energy also. Okay, again this lattice energy word should become in your inter second year syllabus.